Hello everyone and welcome to Lee's R&D session number 10. So here in session number 10 we're going to be putting together the terrain exporter and the terrain viewer that was discussed back in session 9 when we had talked about the new way that Lee had come up with doing terrain for the MMO. In this video here, Lee's going to provide a bit of an overview, I guess really just the terrain exporter, right Lee?
Right. Well, each of these different projects will have its own overview discussing what we're going to be doing and roughly how we're going to approach it.
Right.
So that's what this video is going to be about, is specifically what we're going to try to accomplish with the terrain exporter, what it is, what it does, and some of the limitations that we're going to have with it at this point in time, because we are skipping over the persistent part of the system, that data storage system. So we're going to have to take some things and modify what we're going to do with them and then go from there.
Okay.
And then once we get the persistent system, we'll have to come back and make some modifications to the exporter to work with our storage system. And then that will also propagate into the terrain viewer as well.
That's right. And again, just to point out to all of the students, that was really a command decision that I made so that everything that has been R&D'd at this point is functional. I want it to go ahead and get recorded into video format so that those of you can begin watching these. And then while you are following along with these videos, then Lee can get the persistent system tied in. We'll get with Nelson and get some videos going with him discussing the API for the data store system itself.
Right. So, well, basically, what is this terrain exporter? The terrain exporter is, in essence, 3 systems rolled into one. And let's see, how would I explain it? Basically, in this first part, what we're going to do is we need to be able to build a mesh just like we did before with our terrain editor. Because we don't have the storage system to draw the vertex information from, we're not going to implement a vertex cache here yet. Later we will, but for now we're going to draw the information directly from our handy-dandy terrain generator that we've been using all along since session 1. So we're going to reuse it again, and we're going to pull information from it, and we're going to be borrowing from our terrain mesh class that we had created in the last session. We're going to bring it in, and we're going to make some modifications to it so that we're just going to build these basic meshes, and then that will be the first subsystem of this program, that just to give us some raw information to play with. The second part of it, which gets into some of the fun, is we're going to take that terrain mesh information and we're going to write an OBJ exporter. We're going to be looking at the height information and the normal information and the UV information, and we will be exporting that into an OBJ file, which we'll save to a location on our hard drive that this project will be able to see, and then the Unity editor will automatically start importing it once we create those. So part of the other part of this subsystem is going to be overriding or adding functionality to the built-in FBX importer. I'm going to show you guys how to write an editor extension that will allow us to modify the way the FBX importer works defaultly. So that will be the second subsystem of the 3. Once we've gotten our OBJ exported and then imported back in, we're going to create a prefab from it. So technically that is part of the second one. So we're going to export, import, and create a prefab. Now, after we have a prefab, that would be good for us in this if we wanted to use that prefab, but we don't want to use the prefab in this exporter. We want to be able to export it as an asset bundle that we can then use in our terrain viewer. That's going to get us into the third subsystem that this project is going to have, which is going to be an asset bundle exporter. So technically, this one exporter has two different exporters in it, an OBGA exporter and an asset bundle exporter. Now, the way I'm going to implement the asset exporter is going to be using another editor extension. This particular editor extension is going to have some intelligence built into it such that we can select a single Unity asset and export it as its own asset bundle if we want to. We can select a folder, and then it will give us the option to export all of the assets inside of that folder as a single asset bundle, or it can also break each one up into its own individual asset bundle. And then there's another step that we're going to do that will allow us to recurse through all of the folders. So if we select one of the higher level folders and we tell it to recurse through all of the folders, it will search through all the folders, get all the assets, and then we'll still be able to choose whether or not we want to make a monolithic asset bundle with all of the assets it's found all wrapped up together, or whether or not it will create individual asset bundles for each and every asset it finds inside of that structure. Now, if we choose to create a monolithic or the individual asset bundles, we still need to be able to preserve the directory tree that those assets were found in. So if, let's say, I was in the second subfolder of a tree and I selected to make an asset bundle for every asset underneath that branch in the folder and recurse through every single one of them, what we would find is that the asset bundle exporter will create that file structure, and it will create asset bundles for every asset that it found in its relative positions in a folder external to our project itself, because all of our Unity projects live inside of a folder called assets. And what I want to do is I want to mimic a folder structure outside of that asset folder, but keep the structure that it found internally. So what we're going to do is we're going to create another folder outside of assets that's going to be called data. And then we're going to have our asset bundle exporter reconstruct the structures that are necessary to maintain the directory chain inside of that data folder. So we'll find those asset bundles in the same location that those assets that we flagged to be exported were inside of our assets folder. And we'll be going through the whole process of how to do that.
I have a quick question. So the ability to select individuals and, of course, the ability to do one large asset bundle, any particular reason? I mean, is there any difference between the two exported bundles, the small ones, the large ones that you're going to be using in the terrain viewer, or anything else that you're envisioning?
Well, the way I'm looking at it is there are certain assets that I would like to have grouped together.
Okay.
And I want those to be a cohesive unit, meaning I'm going to keep them as a monolithic asset bundle. The ones that I'm thinking about should be kept together are things like the terrain material, which has a material, it has a texture, it has a normal map, and as our material for our terrain gets more complicated, we will literally have probably dozens of files that will be part of the terrain system. But those are common for every single terrain patch. Mm-hmm. That they may or may not use those. But what I would like to do is keep all of the assets that are that every terrain patch relies on in a single file. That one single file then can be exported as a single asset bundle, and then we can ship that with the client, or we can make sure that it gets downloaded the single time before the game is run.
Okay.
So now that keeps all of those assets nice and tight, and if we decide to have new versions of that bundle, that one bundle gets updated, as opposed to possibly having to keep track of hundreds of little assets that are all needed for the terrain system.
Okay.
Now, that is different than what I would want to do with, say, terrain patches. Because terrain patches, while, yeah, I could, take every single terrain patch, save it in a single asset bundle, it would be kind of difficult to be sending a single terrain patch asset bundle that may be several gigs in size. So that would definitely slow us down. But if I were to break those up in individual pieces, then we have very small asset bundles that can be downloaded very quickly on demand.
Right.
And that's one of the reasons that we want to keep individual asset bundles. Now, the reason that this system came about isn't so much for baking out the monolithic asset bundles. That's a fairly simple process. Even the recursion of it is fairly straightforward. The real reason of this asset bundle exporter being able to recurse and then reconstruct folder structure and export individual asset bundles was dealing with the terrain patches themselves. Just the sheer number of terrain patches that this world is going to contain, or worlds are going to contain, would be very prohibitive if you had to select on each and every patch and export it one by one. We're talking just our one large sample that we demonstrated at the beginning of session 9 was about 6,800, almost 7,000 patches. And if you had to select each patch one at a time, it would be a very time-consuming process.
Yeah, absolutely.
Even using this asset exporter and the whole process, I think it took about 10 hours to run through and export those 7,000 patches. Mm-hmm. Mostly because of, some errors that came in with Unity running out of memory and having to stop and redo some stuff. But it was still a timely process to get the world that large. And when we're looking at the size of the worlds that we're thinking about, that's just a small section of the overall world of a single planet.
Right.
And when we have potentially the idea of multiple planets, we want to have a very streamlined process. Even what we're going to show you in this session isn't what we've got fully envisioned. We'd like to have a refined process where we've got an interface where whoever is going to be basically the terrain patch wrangler will be able to assign sections of patches to be generated at a time. And we'd like to be able to automate the process as much as possible, where the system will bake out all the patches, load them up where they need to go, and then once that section is done, we can move on to the next section, and the next section, and the next section. The reason we have to do this is because the Unity editor has memory leaks in it. I can't create patches indefinitely. At some point, we will run out of memory and the Unity editor will crash. So we have to bake smaller patches of these out, or batches of these patches out, and then make sure that we stay within the limits of what the editor can handle without exploding. Then we shut down the editor, start back up, and it would be nice also if we could automate the process where there was a text file that was written out where the editor could keep track of where it left off in a job. And then when we shut down the editor and start it back up, it goes, I'm about to resume from this spot. Is that correct? And you can hit yes, no, and then it automatically fires up and keeps going from that point forward. Basically trying to keep the work of a person sitting on a machine as little as possible. And what we'll probably end up doing is setting up one of my faster machines and then putting the work on it so I can just let it bake out these patches all day long when we need them, and we can continue R&Ding on my other machine.
Right. Let's go ahead and address something else too, and that is most of our students, of course, are going to be using Unity Standard, which means they're going to have access to just about everything that we're doing, with the exception of working with these asset bundles. That is a pro feature. Now, in session 9, we had mentioned at several points, near the beginning, again near the end, that those of you that are using Unity Standard could go about creating your editor and in-game client all from that system. You don't have to go as far as what we're doing here. Again, what we're doing with the asset bundles and the terrain viewer is setting up a system that will allow us to view very, very large landscapes. Right. Now, we did demonstrate the tweaking that can be done, And you can still get some pretty satisfactory distances that can be viewed in the editor that we worked on in session 9. And then I just wanted to throw out there with what we're doing here in session 10 with the terrain exporter and the terrain viewer. If you're using Unity Standard, you still can follow along because you can still get the prefabs made. You just can't do the asset bundles.
Right. The object exporter is still valid. So you can write the object exporter, build your stuff out as OBJ files. And the part of the pipeline where we discussed taking that into an external modeler, tweaking it around, making it the way you want it, and then re-importing it into Unity is still all valid.
That's right. The only key difference here is that when you shipped a game client, you would need to make sure that all of the prefabs shipped with the game itself.
Right. So you'll be using a much smaller world than what we're doing. But in case of a small, say, adventure game, or even some sort of hack and slash type game where you only needed a dozen, 2 dozen, maybe 100 of these little patches, this is a very valid way of making those small worlds.
Are you kidding? You could still get away with a world the size of WoW if you were going to ship it all as, I mean, look at what World of Warcraft size-wise is these days. What, 25 gigs or so? And the area that you had, that was a pretty big area with the 6,000 some odd patches that were sent out.
Well, the problem that you run into is when you've got those 6,800 prefabs all loaded up into a Unity editor at one time, starts to get a little bit slow.
It's true. Now, but I again, it comes down to a balancing act and tweaking, just finding what the right number is that is going to work for you, which, we could have walked away from things a while back saying, well, it's just not possible, as opposed to testing every different patch size against speeds for creation of collision meshes, etc., to find that perfect balance. And I'm just pointing out that they can do that as well. I just don't want those that are using Unity Standard to go, oh, this whole session here is just irrelevant to me. And I don't think that's the case, not at all.
No, and the thing is this is an object exporter. I mean, you will find threads all over the Unity site when you start looking at people going, hey, how do I get meshes out of Unity? Because people do create stuff inside of Unity with custom meshes, but once they're there, they don't realize that there are tricks that you can do to export those files and turn them into prefabs. And literally, you can... There's what's kind of weird is I went about this in a roundabout way, is the fact that I knew I had my train patches, and it was like going, oh great, so I should be able to turn those into prefabs directly, and I could take my train patches, turn those into prefabs that would show up inside of the project panel. The funny part of it is the moment I stopped playing, those prefabs lost their meshes. So those were still temporary meshes, and they weren't getting saved out, which is why the object exporter came along. So we could take those custom meshes, export them as a file, and then attach those files to our prefabs. And from there was some problems that I had, which is why we've got the terrain processor that adds functionality or modifies the inherent functionality of the FBX importer. The fact that we're exporting as an OBJ just gives us added functionality, and the fact that we are capable of taking one of these terrain patches and dragging it out and throwing it inside of Maya or Max or one of the other programs and just messing around with it. And I did that a while ago. I did that for you. I don't think we did that on video, right?
No.
Yeah. So, but it is completely possible. We tested it and played with it a little bit, and Jason's like, well, what are you doing? Oh, I was just trying you could do it.
We did discuss the rules when doing that on video.
Yeah, and we were talking about the possibility of
a plugin.
Making a Maya plugin that would load these OBJ files in procedurally. So as you selected a patch that you wanted to work with, it would load all of its neighbors in, so we could possibly make sure that all of the boundary vertices stay locked together.
That's right.
Because that's the big trick is you can manipulate all the vertices in a patch all you want. The thing is you want to make sure that neighboring patches match up. Otherwise, you're going to have tears inside of your meshes, and that's going to be an issue. So let's see. What other concerns are there going to be with this? The big one that I can think of off the top of my head is right now, because we do not have the persistent system available, we're not going to be baking out the normals and tangents like we did before. So, or actually we didn't bake them up before, but we're not going to calculate those. Like in the terrain editor, we went through that whole section of writing a new normal calculation method, and we did the tangent calculation method and brought those in, which got rid of the seams for us. We're not going to be using that in this particular version because I don't have the persistent information available to us. There's a limitation with the OBJ exporter in the fact that I can't export tangent information through the OBJ. So if I want to have tangent information, I had one of two options. I would have to write my own exporter and importer to manipulate information that contained the tangent, and that seemed to be too messy. Or what I plan on doing is using this technique with an exporter that brings in the prefabs, and then just before we get into the build asset bundle part of the pipeline, we'll insert another step which will then go back to the data storage system and pull the tangent information. So what will happen is the final process will be having a vertex cache in the system that draws its information from the data storage system. It will then export an OBJ file that can be manipulated. Then from there, just before we build an asset bundle as part of the part of the prefab, we can then update the normal and the tangent information one final time as a pre-process step to the asset bundle export. That makes sure that all of our patches have correct normals and tangents calculated for them. So this will help us with dealing with the process of, let's say we take to Maya and we manipulate and we bring it back in. There's another step which would be a re-import, because I'd like to be able to take the information that was manipulated outside of this program and possibly bring it back into the data storage system so it gets saved there, because what we don't want to do is lose that information forever.
Right.
So,
and obviously if you didn't take it back over into the data store and the next time you baked out those patches, you would
lost all of it.
Lose the information. Yep. Right.
Right. So it would be nice to be able to report that information back in and then recalculate normals and tangents just before we do the asset bundle export to make sure everything is accurate. Now that does get into an interesting subject which we have not covered in R&D yet, which we will have to address, is the fact that if we take our patches to an external program and bring those back in, those patches are going to have to be able to keep track of the potential that those vertex points or vertex points have been manipulated outside of our standard grid, which means that instead of being all lined up in nice rows and columns, those vertices could have been shifted left and right, up and down, as well as or left, right, forward, backwards, as well as up and down in height. So now there's a three-dimensional displacement potential for each of those vertices, which means our data storage system is going to have to be able to keep track of that as well. So basically we'll have to index and go, hey, this vertice should be here. Where is it in reality now? So we'll have to mess around and see if we can't make that work.
Okay.
And so that will be something we'll address later. So to get around this whole problem for now, though, we're just going to use our standard built-in recalculate normals, and we're going to use the calculate tangents method that comes with the FBX importer to get our base tangent and normal information which will be exported into our asset bundles.
Okay.
So
again, the whole idea of the terrain exporter and the terrain viewers, we're just going to take what we've got so far, we're going to work our way forwards and put this architecture together. We will be missing a few parts, but again, I like the idea of doing it from this more high level and then being able to go back and plug in things like persistence, etc. It allows you guys, the students, to begin watching videos sooner. It allows us to stay focused more on the high level of what's going on, and then back up. Everybody at that point should be comfortable with the high level architecture, and then we could start plugging in these more specific areas into the architecture that will be required. So, Lee, if there's anything else you need to say, now's the time. Otherwise, we can get started.
Nope, I think that's it.
Okay, fantastic. Well, that's going to wrap up this quick introduction, and we will see you guys back in the next video where we will get this new project set up. Thanks a lot, everyone.